It's wild to think that in just over a decade, one single market design went from being, well, a Silicon Valley dream to the absolute workhorse of the global space industry. It launches almost every other day, it flies astronauts to the space station, and it's completely changed how we even think about getting to orbit. Today, we're diving deep into the SpaceX Falcon 9. Wow. That's not just some nice compliment, right? That's a huge claim. To say it's the most influential rocket of our time, that suggests it did more than just fly missions. It suggests it completely tore up the old rulebook and wrote a new one.
So the big question is, how did they pull this off? How did a single rocket spark a full-blown revolution? Well, it wasn't one thing. It wasn't some magic trick. It was a whole series of really smart engineering choices and just a relentless, almost obsessive drive to keep making it better. Let's break it down.
To really get the Falcon 9's impact, you got to start with just how dominant it's become. This isn't just about being cool or innovative. First and foremost, it's about being unbelievably reliable. A success rate of over 99% across hundreds and hundreds of flights. Just think about that. In the world of rocketry, where one tiny mistake means everything goes boom, a number like that is just staggering. That's the kind of performance that builds trust and completely reshapes an industry. But here's the thing. That kind of reliability didn't just happen. The Falcon 9 that's flying today looks almost nothing like the one that first flew back in 2010. It is a result of constant, aggressive improvement, what we call iteration. Each new version wasn't just a small tweak. It was a major leap forward. And you can see that evolution right here. It all kicked off in 2010 with version 1.0, which was really just about proving they could do it. Then in 2013, V1.1 came along with much more powerful Merlin engines and that clever octaweb layout. But 2015 was the real game changer. The full thrust version added super chilled fuel for more power, and crucially, it was designed for reusability. And all of that led us to the Block 5, the final, ultimate version we see today, built to fly people and be reused over and over again. And the result of all that work? Just look at the raw power difference. The very first Falcon 9 could get about 9,000 kilograms into orbit. Today's Block 5? It can lift more than 2.5 times that much. It's basically a heavy lift rocket that comes in a medium lift package. So what's the secret sauce? What's the beating heart of this rocket that gives it that kind of performance? Well, it all comes down to the Merlin engine, an absolute masterpiece of propulsion that SpaceX designed themselves for one purpose: to be powerful and reusable. This is a really big deal. In simple terms, this engine is just incredibly powerful for how little it weighs. That high thrust-to-weight ratio is the key to everything. It means the rocket isn't wasting a bunch of energy just lifting its own engines. Instead, that power goes into lifting the payload, which is, the whole point.
And what's really clever is that it's not just one engine. It's really a tale of two engines. The first stage has 9 of them, all clustered together, and they're built to perform best while pushing through Earth's thick atmosphere. But the second stage has just one, a special vacuum version with this huge nozzle that makes it super efficient in the blackness of space. 2 different jobs, one brilliant design. But look, powerful engines and smart design are great, but they were all building towards the one thing, the one idea that completely flipped the industry on its head, making the most expensive part of the rocket come back and land itself so it could fly again. This is the part that still looks like science fiction, right? After it separates, the booster actually flips itself around. These incredible titanium grid fins steer it as it falls back through the atmosphere at hypersonic speeds. Then, right at the last second, it reignites its engines for a final landing burn to slow down for a perfect, gentle touchdown on its 4 landing legs. Just amazing. And how good have they gotten at this? They have stuck the landing nearly 500 times. This isn't an experiment anymore. This is absolute mastery. And these boosters aren't fragile, one-and-done machines. A single booster has flown to space and back again almost 30 times. That is real airline-style reusability for rockets. And get this, they can do it fast. The record for landing a booster, checking it out, and launching it again is just 9 days.
That speed is exactly how they're able to launch so often and dominate the market. Okay, so all this amazing tech, all these landings, what does it all mean? Well, it all comes down to money. Because when you stop throwing away a multi-million-dollar piece of hardware every single time you launch, the price to get to space absolutely plummets. And the savings started right from the very beginning. SpaceX developed this entire rocket for less than $400 million. Now, what would a traditional NASA estimate for something similar be? $4 billion. That's a 10 times difference. It just shows you how lean their approach was from day one. But this chart tells the whole story. Just look at that tiny sliver for fuel. The actual propellant for a launch only costs a couple $100,000. It's practically a rounding error. Almost the entire cost is the hardware. So when you can reuse that hardware again and again, you're saving almost the entire cost of a new rocket on every flight. It's a total game changer. And that's the big picture. This isn't just about SpaceX saving money. It's about what that enables for everyone else. It leads to what people call the democratization of space. Suddenly, getting to orbit isn't just for massive governments anymore. Now, universities, small countries, and startups can all afford to send their projects to space. So when you take a step back and look at the whole picture, the reliability, the reusability, the economics, you start to see the real lasting legacy of the Falcon 9. It's about the new technologies it proved were possible and the historic firsts it achieved. I mean, look at this list: propulsive landing, rapid reuse, grid fins, mass-producing rocket engines. These were all considered radical, almost crazy ideas when SpaceX started. Now, they're becoming the industry standard. The Falcon 9 didn't just win the game, it made everyone else learn to play a whole new one. And the history books will remember these key moments. That first landing in 2015, that was the big one. The first reuse in 2017 proved the whole economic model could work. And then, in 2020, it launched humans, the first time a private company had ever done that, and it brought astronaut launches back to American soil. Just one milestone after another.
So let's go back to that original claim. Is it the most influential rocket of our time? Well, it took something that was incredibly difficult, incredibly expensive, and frankly, incredibly dangerous, and it made it routine. It made access to space ordinary. And its legacy leaves us with this incredible question. What happens next? What amazing things are we going to build? What new worlds will we discover now that going to space is no longer extraordinary?